Hello students, I'm Imkong Lapungan from Department of Anthropology, University of Delhi. Today I'm going to speak on the module Population Projection from the paper Demographic Anthropology. Well, the learning objectives of the modules are: number 1, to understand the key concepts and history of population projection. Number 2, to demonstrate knowledge and understanding of the key concepts used in population projection and forecasting. Number 3, to discuss the main methods demographers use to project or forecast future demographic developments. Firstly, let us discuss briefly about population projection. Human beings evolved under conditions of high mortality due to famines, accidents, illnesses, infections, and war, and therefore the relatively high fertility rates were essential for species survival. In spite of the relatively high fertility rates, it took all the time from evolution of mankind to the middle of the 19th century for the global population to reach 1 billion. The 20th century witnessed an unprecedented rapid improvement in healthcare technologies and access to healthcare all over the world. As a result, there was a steep fall in the mortality and steep increase in longevity. The population realized these changes and took steps to reduce their fertility, but the decline in fertility was not so steep. As a result, the global population has underwent a fourfold increase in 100 years and has reached 6 billion. Population refers to human aggregates within a defined space. Now, the single outstanding fact about the population is the rapidity of its growth in the past 200 years. A rapid, accelerated expansion in the population can be seen since 1750. According to the World Health Organization, 4 human beings are born every second. The net increment works out at 250 per minute, 15,000 per hour, 360,000 per day, or nearly 2.25 million per week. The human population have 2 fundamental characteristics that reduce the uncertainty about how they will develop in the future. Now, the first fundamental characteristic is that a substantial overlap exists between the current population and the future population. Secondly, one fundamental aspect of the human condition is that we grow older by 1 year until we eventually die. These 2 facts constrain possible future developments in a population equivalent in other fields. Methods involved in population projection takes advantage of both these points. Now, a population projection can be defined as a computational procedure to calculate population size and structure at one time from population size and structure at another, together with a specification of how changes take place during the interim period. Now, it can be distinguished from a forecast as it can be defined as a projection based on assumptions that are productive and considered to yield the most probable estimates of the development in the future. It deals with computations of future projection size and characteristics that attempt to peep into the future population scenario by using the assumptions and probability of occurring in future. Projections are merely an intelligent exercise for predicting the fate of current population under specified assumptions of fertility, mortality, and migration. Predicting the future course of human fertility and mortality is not easy, especially when looking beyond much further in time. At the country level, different population projections are made by the government, national and international agencies from time to time. Aiding to it, individual demographers make projections for the country as a whole and sometimes at the subnational level also. World Bank, United Nations Population Divisions, the United Nations Population Fund are among the international agencies who make projections for the world as a whole and also for the individual countries. Now let us discuss about the history of population projection. The need for population projection in India at various levels and by different components like age, sex, rural, urban, etc. for the use by the official agencies uniformly, both at the center and the states, were keenly felt in 1958 on the eve of the formulation of the third five-year plan. Beginning in 1958, it has been customary for the Office of the Registrar General and Census Commissioner India to undertake the exercise of population projection on behalf of the Planning Commission of India. Now, the first expert committee on population projections was set up by the Planning Commission in 1958 under the chairmanship of the Registrar General India to provide a set of population projections for India and the states. The projections up to 1971 were then made available to the Planning Commission pending the release of 1961 census data. Subsequently, with the release of the final population total of the 1961 census, as well as taking into account the life table values of 1951 to 1960, the expert committee was reactivated in 1963 for effecting a further revision of the projections and extending them up to 1981. The committee gave its report in 1964. Out of the three sets of projections, namely high, medium, and low, the second one, that is the medium one, was recommended for official use. Following the release of the 1971 census provisional population totals, the expert committee was once again reconstituted to revise the existing official series of population projections of 1964. The Planning Commission again felt the need for another series of projections based on more recent data and subsequently constituted another expert committee in 1974, which submitted its report in 1978. Now, after the release of the 5% sample data of the 1981 census, Planning Commission reconstituted the Expert Committee on Population Projections in 1984. Population projections for the period 1981 to 2001 were prepared under three assumptions on the basis of trends in fertility. Now, this report was published in 1988 and the medium projections were recommended for official use. In the light of the trends observed during 1980s in major demographic parameters as revealed by the sample registration system, the Planning Commission apprehended that the future size tree of India's population might be higher than that projected by the expert committee. In order to have a fresh look at the projections, the Planning Commission set up a standing committee of experts on population projections towards the end of October 1988. Now, this committee reviewed the medium projections made by the Expert Committee of 1984 in light of the further data available on fertility, mortality, and contraceptive prevalence, that is family planning, and submitted its report in 1989. With the availability of age-sex distribution of population from the 1991 census, the latest data relating to family planning performances and recent levels and trends in fertility and mortality as emerging from the sample registration system, a fresh need was felt by the Planning Commission for a new set of population projections. As such, the Planning Commission constituted a technical group on population projections in 1996 under the chairmanship of the Registrar General India with the following objectives. Okay, the first objective was to review the methodology of population projections adopted in the past. The second objective was to prepare fresh projections of mortality status and parameters of fertility conditions based on changed pattern of contraceptive use and proportion of married females and other characteristics. The third objective was to make population projections afresh up to 2016. The fourth objective was to prepare projections of the possible period when NRR was equal to 1, which would be achieved by the states and the union territories and the country as a whole. Now let us discuss the strategies for projecting population. Two different and contrasting approaches are carried out to calculate population projections. The first method is total method. Now it calculates the trends in the size of the population as a whole by using the mathematical model of population growth. It may further distribute into subgroups in ratio to the current structure of the population. Secondly, we have the cohort component methods. It projects each age group, sex, and other category of interest separately. Aggregated results are used to obtain the total population. The term cohort indicates to the age group of people born at the same time who go through life together. The size of a cohort at age 1 is strongly predictive of its size at other ages. Many population projections are combined through approaches, although projections are largely dominated by the cohort component approach. Now, cohort component methods further require many more input data and assumptions than the total methods. Total methods of projection involves fitting a mathematical model to the data based on past trends in the size of the population. Now, the main steps involved in the procedure are selecting an appropriate model of the growth process, estimating the parameters of the model of the growth process, extrapolating the fitted curves, and rid of the projected population. The four mathematical functions used to model population growth are zero population growth, arithmetic growth, exponential growth, and logistic growth. Now let us see each of these population growth model in detail. Firstly, we will discuss about zero population growth. Now, zero population growth model is the simplest model of population growth where there is a zero population growth. It also assumes that the size of the population is unchanging. This assumption is implied even if one only has a single existing estimate of the size of the population which can project its size at other dates. This figure demonstrates the zero population growth model. Now let us see the arithmetic growth. The next simplest population projection model is that of the linear growth or the arithmetic growth. The model assumes that a constant numeric change occurs in the size of the population in every period of the same length. A minimum of 2 estimates of the population for different dates were required to estimate the annual increment in the population and to also project the size. The model can be fitted to a longer series of population estimates by means of simple linear regression of population size on time. Thus, if we say that PT refers to the population at time t and t plus n refers to the population n years later, then we have this mathematical formula P into T plus N equals to PT plus AN to N, where A is the constant annual increase in the population. That is, A is equal to P within bracket T plus N minus P into T divided by N. Now let us see the exponential growth model. Instead of assuming the population by a constant amount, the exponential model assumes that the population is growing at a constant rate. The growth rate tends to be negative if the population is shrinking over time. A constant negative growth is described as exponential decay. For the purpose of projecting population forward or backward, one requires to estimate its growth rate. A minimum of 2 estimates of the population by means of a linear regression of the log of population size on time. Now in this model, P into T plus N equals to P into T into ERN, where R is the constant growth rate and R equals to log of P into T plus N divided by PT divided by N. The exponential model can further be used to estimate the doubling time of a population with a constant growth rate, the time when the population takes to double its initial size. The general exponential model equation thus goes P into T plus N equals to PT into ERN. When the population is doubling every n years, N equals to log of 2 divided by R, which is equal to 0.693 divided by R. Now let us see logistic growth model. The logistic growth model of the population growth is applicable when the growth rate slows over time, eventually when it drops to 0, a point where the population stabilizes. The equation for logistic model goes as P into T equals to P into 8 divided by 1 plus E minus S within bracket T minus H, where P into 8 represents the final size of the population growth and time is measured relative to point H, date at which the population reaches half of its final size. And S determines the growth rate R at each time it reaches its final size. That is, R equals to S within bracket 1 minus P into T divided by P into 8. Thus the growth rate declines over time to 0, equaling S by 2 at time when the population reaches half its final size. Now let us see the cohort component method population projections. It models the age-sex structure of population and components of their demographic change, that is, fertility, mortality, and migration. Welfton, in 1930s, developed the procedures for making cohort component population projections. It can be considered as an elaboration of the ideas encapsulated in the demographic balancing equation P into T plus N equals to P into T plus B into T minus D into T plus I into T minus E into T, where PT is the population at time T, BT and DT are number of births and deaths occurring between T and T plus N, I into T and E into T are the number of immigrants and of immigrants from the country during the period T to T plus N. There are two possible ways of joining a population. One can be by taking birth into it, and the other can be by migrating into it. Similarly, the only ways to leave a population are to immigrate or to die. Well, this figure shows the steps of a cohort component projection. Now, in order to carry a cohort component projection, detailed assumptions of size and structure of the baseline population has to be made. Each of the components for population growth is to be covered by the projection. Baseline projection has to be subdivided by age and sex, sex-specific life tables for each projection interval in the projection, age-specific fertility rates for each projection interval in the projection period, age and sex-specific net migration for each interval in the projection period. Now let us discuss the steps for population projection. The steps required to project a population are: calculate members of each living age cohort surviving the current projection interval. The immigrants to each cohort are added and the immigrants are subtracted. Number of births are calculated during current projection interval and are further divided into boys and girls. Further, calculate the births of each sex at the end of the projection interval and adjust for net migration into the youngest age group. The next projection interval is calculated. The method does not require an assumption of constant vital rates, and different assumptions are made about fertility, mortality, and migration. Now, the key points to remember about cohort component projections are: the model requires and makes full use of information on the population change component. It provides estimates of the future population by age and sex. The calculations involved are more mathematical exploration of the total population and can be easily done in a spreadsheet. Now let us summarize the module. A population projection calculates the population size and structure at one time from population size at another based on assumed population change over time. A population forecast is a kind of population projection that aims to predict the future population size and component of the population. Extrapolated trends in the growth of the total population or age and sex-wise cohort projection is used to project populations separately by using assumptions about age-specific rates of fertility, mortality, and migration. The total method of projection involves straightforward calculations and minimal data. It also feeds a mathematical model to data on past trends in the size of the population and extrapolating the fitted curve to project population at other dates. Now, the cohort component method of population projection involves age and sex-specific input data, and it also projects the age and sex structure of the population. It carries out one step at a time for 1 year or 5-year projection intervals. That's all for this module. Thank you so much for listening.